We built exact replicas. We brought the best engineers, the best equipment, and the sharpest minds modern construction has to offer. And when they stood in front of the real thing, not a textbook drawing, not a computer model, but the actual stones, they failed. Not dramatically, not with explosions or collapses. They failed quietly. They failed with math. The numbers simply didn't work. And that quiet failure is far more unsettling than any dramatic breakdown could ever be. Because here's what they ran into. The structures that supposedly primitive, pre-industrial civilizations built thousands of years ago, before steel, before hydraulics, before engines, they weren't just big. They were precise, surgically, almost impossibly precise. And when modern engineers tried to replicate, not the size, not the scale, just the tolerance, the gap between two stones, they couldn't do it. That's where this story starts. Not with ancient aliens, not with conspiracy theories, with engineering, with materials, science, with the very hard, very measurable fact that something about what those people built does not match what we say they were capable of. If this is the kind of history they don't want you asking about, the kind that lives in measurements and stones rather than classroom narratives, stay with us. There's a lot more of this kind of content here, and it only gets harder to explain from here. Let's go to Egypt first. Let's talk about a number that the official story has never been able to get comfortable with. When Egyptologist Sir William Flinders Petrie surveyed the Great Pyramid in 1880 and 1881, and Petrie was the most rigorous field surveyor of his era, a man who invented modern archaeological methodology. He measured the joints between the casing stones on the outside of the pyramid. Those casing stones, the finished white limestone blocks that originally covered the entire exterior. And what he found was this. The mean gap between those stones was 0.5 millimeters. Half a millimeter, the width of a few sheets of paper, across blocks that weigh an average of 2.5 tons each. Let that settle for a second. Half a millimeter, across stones the size of a small car, over a structure that covers 13 acres. Petrie himself called it the finest optician's work he had ever seen on that scale, and he said he knew of no modern building that matched it. That was the 1880s. Here's the uncomfortable question. Can we match it now? In 1978, a team of Japanese researchers decided to find out. They set out to build a small replica of the Giza pyramids, not the full pyramid, a 20-meter version, proof of concept, using primitive tools, the way the textbooks say it was done. What happened? They couldn't move the stones. They planned on using 4-ton blocks and had to cut them down to 1 ton. They planned on wooden rafts and boats for transport. Those methods failed entirely. They ended up using electric saws just to cut the stone to shape. A modern research team with modern understanding of engineering and physics, trying to replicate what Bronze Age workers supposedly did with copper chisels, and they had to cheat just to finish the experiment. But here's the part no one emphasizes. Even with the modern saws, even with the reduced weight, even with all of that, they never got close to 0.5 millimeter tolerances. They never got close to the optical precision Petrie measured 140 years ago on the real thing. The official story says this was done with ramps, sledges, water lubrication, and enormous labor forces, maybe 20,000 workers. The ramp theory, the idea that the Egyptians built earthen ramps and dragged the stones up, has been the dominant explanation in textbooks for decades. There's just one problem with ramps. Do the math. To drag a 2.5-ton block up a ramp, steep enough to reach the upper sections of the pyramid, which stands 481 feet tall, you need a ramp of such length and volume that it would require more raw material than the pyramid itself. Some calculations put the ramp at over 8 million cubic meters of material just to service the top third of the structure. And then, once the pyramid is done, you have to remove all that ramp material. There is no archaeological trace of it. None. Not a compacted earth remnant, not a fill deposit, not a quarry trace matching that volume. The ramp theory doesn't fail because it's impossible in principle. It fails because the numbers are absurd. The solution to the mystery requires a second mystery just as big. And here is where it gets uncomfortable. Think about what precision at 0.5 millimeters actually requires in practice. Not in theory. In practice, any structural engineer will tell you that level of flatness and fit on a multi-ton stone block requires grinding. It requires either lapping the surfaces against each other repeatedly or using precision measuring instruments to verify the surface before placement. Opticians do this. Precision machinists do this. This is the language of modern tooling, not ancient quarrying with copper. Some researchers in materials science have pointed out that to achieve a joint that tight across the full face of a large block, you need an absolutely flat reference surface to work from a master flat. In machinists' terminology, or you need to grind the two stones against each other until they conform perfectly. Either method requires either very sophisticated flat reference stones or enormous time and labor just on surface preparation, per block, for 2.3 million blocks. Coincidence? Possibly. But a coincidence that sits suspiciously close to a technical threshold we only crossed in the industrial era. Now let's leave Egypt, because this isn't just Egypt. If that alone is hard to explain, what comes next is genuinely difficult to account for. Lebanon, the Bekaa Valley. A site called Baalbek. If you haven't stood in front of the trilithon stones, the photographs don't prepare you for the reality. But let's try. The Temple of Jupiter at Baalbek is built on a foundation. Part of that foundation, the western wall, contains 3 stones. 3 individual limestone blocks, each one roughly 62 feet long and 14 feet high. Each one estimated at between 750 and 800 tons. They are fitted together, side by side, sitting approximately 20 feet off the ground, placed with minimal gaps between them and the surrounding foundation blocks. The standard explanation is that Roman engineers moved them from a quarry approximately half a mile away. Now, 800 tons. Let's give that weight a frame of reference. The largest operational mobile crane in the world today, the Liebherr LTM-1 1200 to 9.1, has a lift capacity of around 1,200 metric tons under ideal conditions. Ideal conditions meaning outriggers fully deployed, load directly overhead, minimal radius. Moving a load across terrain is an entirely different calculation, and modern cranes with capacities over 500 tons, the kind that build skyscrapers and oil rigs would, according to structural engineers who've studied Baalbek, struggle to transport and position stones of this magnitude across 800 meters of uneven ground. We're talking about stones the Romans supposedly moved without steel cables, without hydraulic jacks, without an internal combustion engine anywhere on the planet. But that's not all, because in 2014, a team from the German Archaeological Institute was excavating in the limestone quarry adjacent to Baalbek, and they found something underneath the stone of the pregnant woman itself, already estimated at around 1,000 tons that stopped them cold. Another stone, buried beneath it, measuring approximately 64 feet by 19.6 feet by 18 feet, weighing an estimated 1,650 tons. One stone, 1,650 tons. The largest known quarried stone in human history. It was cut free from the bedrock on all sides, shaped, finished, ready to transport, and it never moved. The German Archaeological Institute's own assessment, it was probably too massive to transport. Sit with that for a moment. The people who built this place, whoever they were, quarried a 1,650-ton block of limestone, shaped it, and then apparently realized, or were forced to accept, that even they couldn't move it. But they moved the 800-ton ones across half a mile of terrain and set them 20 feet in the air, with minimal gaps. We're not at the core of this yet, because the deepest problem isn't the weight. Weight is a logistics problem. Enormous, staggering, generation-defining logistics, but still logistics. The deeper problem is the precision. It keeps coming back to the precision. At Baalbek, the trilithon stones were fitted with such accuracy that the gaps between them are, in multiple locations, barely enough to slide a piece of paper through. 3 blocks, each weighing 750 tons, set side by side to paper-thin tolerances. Theories proposed to explain the transport include wooden rollers, earthen banks, sledges, counterweights, and coordinated human labor in the thousands, possibly tens of thousands. But here's what no theory yet proposed has adequately addressed. How do you micro-adjust an 800-ton stone when you're sliding it on wooden rollers with thousands of workers pulling rope and it needs to move 2 inches to the left? How do you do that? How do you do that without cracking it, without shifting the stones already placed, without a millimeter scale correction on an object weighing 1.6 million pounds? No consensus exists on the specific transport method. The theoretical methods proposed have not been experimentally validated. That's not fringe archaeology talking. That's the current state of the peer literature. Let's go north. Let's go to England. Let's go to a field on Salisbury Plain, where 4,000 years ago, somebody dragged stones across 200 miles and stood them upright in a pattern that still aligns with the sunrise on the summer solstice to within fractions of a degree. You know the site, Stonehenge. And you probably know the official explanation. Wooden sledges, ropes, rollers, enormous communal effort. The inner ring of smaller bluestones, each weighing up to 4 tons, sourced from the Preseli Hills in Wales, roughly 200 miles away. The outer sarsen stones, some weighing up to 25 tons, from quarries about 25 miles north. In 1997, a team of researchers organized an experiment for a PBS documentary series called Secrets of Lost Empires. They assembled 130 people and attempted to pull a 40-ton concrete replica on a sledge placed on wooden tracks. They greased the tracks, they coordinated the pulling, and they still couldn't move it. They gathered more people, had some use levers while others pulled, and eventually got it to shift. But even then, the research team was uncertain whether this approach could have transported the largest stones 25 miles over real terrain. A 2001 experiment tried to move a large stone from Wales to Stonehenge along the land and sea route archaeologists propose. Volunteers pulled it with great difficulty over modern roads with low-friction netting to assist. The conclusion of the researchers was that it would have been, in their words, incredibly difficult, even for the most organized tribal group, to have pulled large numbers of stones across the densely wooded, rough, and boggy terrain of West Wales. Modern roads, low-friction netting, and still incredibly difficult. But here's the thing that gets overlooked in every Stonehenge conversation. Moving the stones isn't actually the hardest part. The hardest part is the joints. Look at the standing stones. At the top of the uprights, the vertical stones, there are carved tenons, rounded protrusions, that fit into corresponding mortise sockets carved into the underside of the horizontal lintels, sitting on top. Tongue and groove joinery. In stone, on multi-ton blocks, achieved without metal tools. And those lintels, the horizontal capstones, they aren't flat on their outer edges. They're slightly curved. Each one is shaped to follow the circumference of the circle, so that when placed side by side, they form a continuous, gently arched ring. Somebody with no blueprint, no CAD model, no precision instrument beyond a stretched cord and a carved bone, curved each individual lintel to the right radius and fit them together into a perfect ring at the top. The sarsen uprights themselves were dressed surface finished to a level of smoothness on their inner faces that served no structural purpose. You don't need smooth stones to hold up other stones. There was something else going on, a standard of finish applied to 2 5-ton blocks of one of the hardest natural sandstones on Earth, dressed with stone tools. Recent experiments suggest that while it's possible to move Stonehenge-sized slabs with ropes and manpower, it would require thousands of hours of coordinated effort, and even then, without modern measuring equipment, the precise, astronomical alignment might not be achievable at all. Think about that for a moment. Not the moving, the alignment. Stonehenge is oriented to within a fraction of a degree to both the summer solstice sunrise and the winter solstice sunset. The alignment has been confirmed by modern astronomical surveys. A civilization that, according to the accepted timeline, had no writing, no metal tools, no formal mathematics, no permanent settlements of significant scale, somehow achieved an astronomical alignment accurate enough that we still use Stonehenge as a demonstration of prehistoric astronomical knowledge. How do you survey to a fraction of a degree without instruments? How do you communicate the required orientation across a construction project that, by estimates, took decades to complete in phases? Now let's do something that the textbooks almost never do. Let's lay the data points side by side. 1. The Great Pyramid of Giza. Mean joint tolerance between 2.5-ton casing stones, 0.5 millimeters. A precision-level Egyptologist, Flinders Petrie, described as comparable to an optician's work. A precision modern experimental teams with modern power tools have not been able to replicate at scale. 2. Baalbek, Lebanon. 3 stones, each 750 to 800 tons, set to paper-thin tolerances at height, moved from a quarry half a mile away by a civilization that had no steel cable, no hydraulic equipment, no diesel engine, and in the same quarry, a 1,650-ton block, the largest known quarried stone on Earth, cut free, finished, and left behind, because according to the German Archaeological Institute's own conclusion, it was probably too massive to transport, even for them. 3. Stonehenge. 4-ton bluestones hauled 200 miles, 2 5-ton sarsens dressed to unnecessary smoothness, curved lintels, fitted with mortise and tenon stone joinery, the whole structure aligned to the solstice within fractions of a degree by people who, the textbook says, had no writing and no metal. 4. Every attempt by modern engineers to replicate these achievements, not the full scale, just a partial demonstration, has required modification. Reduced stone weights, modern cutting tools, additional personnel, modern roads, low-friction materials, and none of the replications have matched the original tolerances. Here's the inversion that changes the whole picture. We assume the ancients were at the beginning. We assume they were primitive. We assume that because their tools were simple, their results must have been simple too. And when the results don't match that assumption, we call it a mystery and move on. But what if the assumption is the problem? What if precision is not a function of your tools alone, but of your knowledge? What if there is a form of applied knowledge about stone, about mass, about surface geometry, about force that those builders possessed and that we have not yet reconstructed? Not supernatural, not extraterrestrial, just a body of technical understanding developed over far longer and applied with far more mastery than the timeline we've been given allows for. The data doesn't say that. Let's be clear, the data says the results shouldn't be possible with the tools and timeline attributed to them. That's different from knowing what they actually used. But the gap between what we know they didn't have and what the stones prove they achieved that gap has never been closed. Not in 1880, when Petrie measured it. Not in 1978, when the Japanese experiment failed. Not in 2001, when volunteers couldn't move a single stone across Wales on modern roads. Not today. The official version says this is a solved problem, or nearly so. The stones say something else. And here's what makes it genuinely difficult to set aside. These are not isolated anomalies. Egypt, Lebanon, England, 3 continents, 3 cultures, 3 completely separate historical contexts, and the same pattern appears. Stones too heavy to move by the methods attributed to them. Tolerances too fine to achieve with the tools attributed to them. Alignments too precise to survey with the instruments attributed to them. Coincidence? Possibly. But a coincidence that spans 3 continents and 4,000 years of history is either the most extraordinary run of luck in the archaeological record, or it's pointing at something we haven't been willing to look at directly. The question isn't whether ancient people were intelligent. Of course they were. Intelligence isn't in question here. The question is whether the specific technical knowledge required to produce these specific results, the 0.5 millimeter joint, the 800-ton stone, set 20 feet high with minimal gap, the solstice alignment accurate to fractions of a degree, whether that knowledge was developed independently, from scratch, in multiple locations, within the timeframes the accepted chronology provides. Because if it was, then the accepted timeline of human technical development has a gap in it, a big one. A gap where a level of applied engineering existed that we have never found a satisfactory origin story for. And if it wasn't developed independently from scratch, if there was transmission, inheritance, a body of knowledge passed from somewhere older, then the question becomes, where did it come from first? And what happened to it? That question is older than archaeology. It was being asked before the discipline existed, and despite every expedition, every survey, every experimental replication attempt, the stones have not answered it yet. What stands above the ground is only half the story. There are sites where the more troubling data isn't on the surface at all, it's underneath, in chambers that were never supposed to be found, sealed behind walls that don't appear on any official map. That's where this channel goes next.